Okay, class, today we are doing WIF review set 3, slide 7. We're going to round these factors and then we're going to find the estimated product. So I'm going to round to the largest place value for each number. So for 498, I'm going to round to the hundredths place. I'm going to look at the number to the right. It's a 9. You could either do 4 or less, let it rest, or 5 or more, add 1 more. So I'm going to add 1 to the hundredths place value. That makes it 5. My numbers to the right become a 0. Let's go ahead and do 23. We're going to round 23. We look at the number to the right. We've got 3. 4 or less, let it rest. When I'm resting, you don't mess with me, meaning you add nothing. The numbers to the right become a 0. So then we're going to find the product. Product means multiply. So we're going to take 500 and we're going to take 20. And I have 3 zeros. I can box them, cross them, bring them down. And then 5 times 2 is 10. So my estimated product is 10,000. Moving on to 37, it says how many acute, obtuse, and right angles are in this shape. I want you to hold up a little triangle and be like, acute. Okay, that's an acute angle. It's very small. It's less than 90 degrees. So it is, acute is less than 90 degrees. Obtuse, make a big old angle. Obtuse, it is greater than 90 degrees. And a right angle is exactly 90 degrees. So let's see. All right, remember how I showed you guys how we could take like a piece of paper and show that would be my 90 degrees. So this angle is going to be obtuse. Well, same with this one over on the right. That's going to be obtuse. This angle again, if I go like that, that's going to be more than 90 degrees. So that's obtuse, which means that one is as well. It would help if the boxes were there, but you should know that a squared box like that is going to be a right angle. So we have 4 obtuse and 2 right angles. This is asking which is a right triangle. A right triangle will have 1 right angle. An acute triangle will have all acute angles, and an obtuse triangle will have 1 obtuse angle and 2 acute. So the first one, those are all super tiny. So this is an acute triangle. This one has 1 right angle and 2 acute, so this is my right triangle. So my answer is B. Here, it's asking which has a line of symmetry. Remember, symmetry is like when you cut it in half and you could fold it in half, that it is exactly the same on both sides. Excuse my very bad drawing of a star, but the picture on the screen shows that the star is a line of symmetry. Now, on my triangle, this side does not match this side. But if I wanted to show a line of symmetry, I could just go straight down the middle, and then this left side would equal the right side. But the way they did it does not show a line of symmetry. Okay, moving on to 40, it says determine which numbers best complete the pattern below. So we went 94, 85, 76, 67, 58. Notice that the numbers are getting smaller. If the numbers are getting smaller, we are either going to subtract or divide. If the numbers get bigger, we're going to either add or multiply. Well, because the numbers are getting smaller, we're going to either subtract or divide. Subtraction's easier, so we're going to subtract and see how we do. All right, so to get from 94 to 85, I'm going to go ahead and just subtract these two, see what my difference is. My difference is 9. I went down by 9. Let's see from 85 to 76. See if that pattern continues. It did. I subtract by 9. Each time I'm subtracting by 9. So what you need to do is you need to take the 58 and subtract 9 because that pattern continued. $49. Well, this says 47, this says 40. Those are both trash. We have a 49 and a 49, so let's keep going. Now we have to take, so we're going to do 49 here. We're going to subtract 9, and we get 40. This was 58, this was 40, so C is our answer. That's how you determine that. So when it gets smaller, you subtract first, then try division. If the number's getting bigger, you're going to multiply or add. Try addition first always. Try to find that what is different in it. I hope you did well on this today. And this was our last one for